Corporal James Prosser of the Royal Tank Regiment climbed into a Centurion Mark III on the morning of October 4th, 1953, secured the hatch and waited for the countdown at Emu Field, South Australia. The tank sat 500 yards from ground zero. Inside the turret, engineers from the Fighting Vehicles Research and Development Establishment at Chertsey had strapped instruments to record temperature, pressure and shock. Prosser was not aboard when the device detonated. The crew had withdrawn hours earlier. What remained was the tank itself, engine running, gearbox in neutral, a full basic load of 20-pounder ammunition in the racks. Operation Totem 1 released roughly 10 kilotons at 0700 local time. The fireball scorched the desert. Steel poles nearer the tower vaporized. Sheep tethered as biological test subjects were flash-burned to bone. When the assessment team drove out from the observation trenches 90 minutes later, they expected to write off Centurion 169041 as a wreck. The tank was still running. The engine had consumed its own fuel and stopped only when the tank was empty. The aerials had melted. The lamps had shattered. Canvas and rubber fittings on the exterior had ignited and burned away. But the hull was intact. The turret traversed. The breech of the 20-pounder opened cleanly. The FVRDE crew logged the observations in a red-bound notebook that now sits in file W0195 at Kew. The tank was recovered, patched and returned to Australian Army service. It fought in Vietnam with the 1st Armoured Regiment 15 years later, took an RPG hit near Coral Base in 1969, was repaired again and served on into the 1970s. Australian crews called her the Atomic Tank. The story is often told as trivia. In Whitehall it was treated as strategic intelligence. The Chiefs of Staff Committee had commissioned the trial, not for spectacle, but to answer a question Field Marshal Sir Gerald Templar had been pressing since 1952. Could British armour survive the opening minutes of a nuclear war in Germany? The Joint Intelligence Committee had assessed that any Soviet thrust across the North German plain would be preceded by tactical nuclear strikes on NATO forming up areas. Templar's staff at the War Office needed to know whether the British Army of the Rhine would exist as a fighting force 90 seconds after the first flash. Totem 1 gave them their answer, and the answer travelled quickly. By the summer of 1954, the Directorate of Royal Armoured Corps had circulated a classified summary to armoured brigade commanders in Farling-Bostel and Detmold. The Centurion, designed at Barnbow in Leeds during 1943 as a counter to the Tiger and Panther, had survived a weapon of a wholly different order. Its 118mm glacis plate, its cast turret, its Meteor engine derived from the Merlin that had powered Spitfires 8 years earlier. All of it had held. In Moscow, the response was slower and stranger. GRU officers working the Australian station forwarded fragmentary reports through 1954. The Technical Directorate at Kubinka, the Soviet armour proving ground west of Moscow, could not initially reconcile the British claim with their own trials. Soviet T-54 hulls exposed to comparable Semipalatinsk yields had suffered internal spalling, ammunition cook-off, and hatch deformation that jammed crews inside. Something about the Centurion's construction was producing a different result, and the men at Kubinka wanted to know what it was. The file that would eventually be requested through GRU channels bore a Chertsey reference number the Soviets did not possess. What they had was rumour, radio intercepts from Emu Field, and a growing conviction that the British had done something the Red Army's designers had not. Leslie Little joined AEC's Southall Works in 1938, and by 1943 was drafting armour schemes at the Department of Tank Design in Chobham. He was not a celebrated engineer. He appears in almost no photographs from the period. His signature, however, is on the outline drawings for what the department then called a 41, the vehicle that would become the Centurion. Little worked to a specification issued by the General Staff in the summer of 1943 through Major General Campbell Clark, Director General of Artillery, and Claude Gibb at the Ministry of Supply. The requirement was blunt. The next British tank had to defeat the German 88mm gun at 1,500 yards and mount a 17-pounder capable of killing anything the Wehrmacht could put in the field. That specification and the men who wrote it produced the features that would matter at Emu Field a decade later. The A41 was to weigh no more than 40 tons, a limit set by the width of the standard British military bridge. But the tank board authorised an increase to 45 tons in October 1943 on Little's argument that survivability required it. The extra weight went into the hull. Rolled homogeneous armour at the front reached 3 inches at 57 degrees. The turret was cast in a single piece at the English Steel Corporation Works in Sheffield, a foundry that had spent the previous 3 years producing naval gun houses for the home fleet. The casting technique developed for battleship turrets produced a grain structure in the steel that dispersed shock loads through the mass of the metal rather than concentrating them at welded joints. 6 prototypes were ordered from AEC in February 1944. They were completed in 6 weeks. 20 pre-production vehicles reached Belgium in May 1945, 6 days after the German surrender, too late for combat. The army retained them. Field Marshal Montgomery, then commanding the British Army of the Rhine, wrote to the War Office in July 1945 that the Centurion was the first British tank he had inspected, which he considered a match for anything the Soviets fielded. He requested full production. Attlee's government, elected the same month, had inherited a bankrupt exchequer and a defence estimate that consumed nearly a fifth of national output. Hugh Dalton at the Treasury wanted armoured production cut. A.V. Alexander at the Ministry of Defence, backed by the Chiefs of Staff, argued that the Centurion had to continue. The compromise reached in October 1945 authorised production at Vickers Armstrongs, in Elswick, at the Royal Ordnance Factory Leeds and at Vickers Barnbow. First deliveries to the British Army of the Rhine began in December 1946. By 1950, the Centurion Mark III mounted the Ordnance QF 20-pounder, a 84mm gun that could penetrate 250mm of armour at 1,000 yards. It was the most powerful tank gun then in NATO service. When the Korean War opened in June 1950, C Squadron of the 8th King's Royal Irish Hussars deployed to Pusan with Centurion Mark IIIs. At the Imjin River in April 1951, Centurions of the 8th Hussars supported the withdrawal of the Gloucestershire Regiment from Hill 235, covering the rifle companies with direct fire from ridgelines that Sherman crews had said were untankable. Captain Peter Ormrod's troop climbed slopes of 32 degrees to reach firing positions. The Centurion's horseman suspension, another little contribution, held. Korea confirmed what BAOR trials had suggested. The tank could go where its designers had not planned. The question by 1953 was whether it could survive what its designers had never imagined. The answer to that question was being loaded onto a transport ship at Portsmouth, bound for the Woomera prohibited area and a tower 40 feet high in the South Australian desert. The Chiefs of Staff Committee met in Great George Street on March 12, 1953, to approve British participation in Operation Totem. The minutes released to the National Archives in 1984 under file DEFE 4/61 record Sir John Slessor, Chief of the Air Staff, arguing that the trials would generate data unavailable from Britain's own Montebello test the previous October. Slessor was blunt about the strategic context. Soviet occupation of Eastern Europe had placed 30 divisions within striking distance of the Elbe. NATO's conventional forces in Germany numbered 12 divisions. The gap could be closed only by tactical nuclear weapons, and the survival of Allied armour in a nuclear battlefield was, as Slessor put it, a matter on which planning could no longer wait. Field Marshal Sir John Harding, the Chief of the Imperial General Staff, supported the request. Harding had commanded the 7th Armoured Division in the desert, understood the vulnerability of armoured formations to concentrated fire, and had read the intelligence assessments from JIC 53-14, which projected that a Soviet offensive in Central Europe would open with 20 to 40 tactical nuclear strikes on NATO forming up areas within the first 6 hours. The Centurion equipped 9 armoured regiments in Germany. If the tank could not survive such conditions, BAOR was a paper force. The trial specification was drafted at FVRDE Chertsey by Dr. E.B. Cole and passed to Group Captain Charles Adams, the Air Ministry's technical liaison at the Australian Weapons Research Establishment. Adams flew to Salisbury, South Australia, in April 1953 to coordinate with William Penney, the physicist who had led the Montebello test and was preparing the Emu Field program. Penney was already carrying the weight of Britain's independent deterrent. He had been the British observer at Nagasaki in 1945, had built the Hurricane device on a converted frigate in the Montebello Islands the year before, and was now moving the trials inland to test smaller, air-deliverable designs. The Centurion selected was Army registration number 169041, a Mark III built at Barnbow in 1951, engine hours logged, gearbox and hull certified to standard by the Royal Electrical and Mechanical Engineers. It travelled from Portsmouth aboard the SS Empire Grabe in May 1953, was landed at Port Adelaide and driven by rail flat to the Woomera Transit Yard. From there, a low loader took it 300 miles northwest into the Great Victoria Desert. The final approach to Emu Field was over a rough graded track known as the Anne Beadle Highway, a route surveyed and cut by the Australian government surveyor whose name it bore. Penney's team positioned the tank at Point Alpha, precisely 460 yards from the shot tower. Instruments were fitted in 3 stages. Thermocouples were welded to the glacis, the turret roof, and the engine deck. Piezoelectric pressure gauges were sunk into the fighting compartment. High-speed cameras in blockhouses at 3,000 and 6,000 yards would record the flash and the shock front. FVRDE required the tank to be operational at the moment of detonation. Engine running, fuel to 2/3 capacity, ammunition stowed as if for combat, hatches closed. The instruction was signed by Cole and countersigned by Penney on September 30th, 1953. The device on the tower was a plutonium implosion weapon with a beryllium reflector, a design intended to test the yield efficiency of a lighter core than that used at Montebello. Penney predicted 10 kilotons. The firing panel was located at Roadside, 17 miles south. At 0700 on October 15th, the countdown began. It halted at 8 minutes for a weather check. At 0715, the sequence resumed. At 0730, the device fired. The observation officer at Roadside recorded a fireball of 400 meters diameter within 1 second of detonation. The shock front reached the Centurion at approximately 1.2 seconds. High-speed film later processed at Aldermaston showed the tank displaced bodily rearwards by 5 feet, the antennas whipping and severing, the exterior stowage bins detaching and flying downrange. Thermal pulse temperatures on the glacis plate reached by the thermocouple record 3,200 degrees Fahrenheit for a fraction of a second. Paint carbonized, the rubber pads on the road wheels ignited, every non-metallic external fitting failed. The tank continued to run. The Meteor engine, drawing air through filters designed for desert operations in North Africa a decade earlier, kept turning until fuel exhaustion at approximately 0945. When the FVRDE recovery party reached Point Alpha in a Land Rover fitted with radiation instruments at 1020, they found the hull warm to the touch but structurally sound. Cole opened the driver's hatch with a spanner. The interior was intact. The 20-pounder rounds were undisturbed in their racks. The optical periscopes had cracked, but the gunner's telescope was serviceable. Cole's initial handwritten report, later typed and filed as FVRDE Report number 47/54, concluded that a crew inside the tank at the moment of detonation would have suffered severe injury from shock and blast, but would not have been killed outright by the weapon effects on the vehicle. That conclusion travelled up the chain in stages. Cole's report reached Chertsey by air freight on November 3, 1953. It was digested by the Directorate of Weapons Development at the War Office and circulated in summary to the Chiefs of Staff on November 18th. Harding read it in his office at the War Office and, according to a marginal note in DEFE 5/49, wrote a single word in pencil in the margin. Excellent. The full text was distributed to armoured brigade commanders in Germany in the spring of 1954. Major General Reginald Hull, commanding 7th Armoured Division at Farlingbostel, received his copy in April and had it read to squadron leaders at a divisional study day. Hull's staff drew practical conclusions. Tank tactics in the nuclear environment would emphasise dispersion, hull-down positions on reverse slopes and rapid movement between engagements. Crews would fight closed down for extended periods. Nuclear biological chemical filtration, still crude in 1954, would be developed as a priority for the Centurion's eventual successor. The requirement that would become the Chieftain was already being shaped by Emu Field. In Moscow, the technical directorate at Kubinka was working with a different picture. Soviet trials at Totskoye in September 1954, conducted under Marshal Gorgy Zhukov's direct supervision, had exposed a mixed force of T-34/85s, T-44s, and early T-54s to a 40-kiloton airburst. The Soviet report, later partially released in the Yeltsin-era declassifications of the 1990s, recorded significant internal damage to hatches, optics, and ammunition storage. Vehicles at comparable distances to the British Centurion suffered burn-through of external fuel drums, spalling of interior armour surfaces, and, in 2 cases, deformation of the turret race that jammed rotation. The Kubinka engineers, working through the intelligence summaries that GRU had assembled from Australian and British open sources, could not initially explain the discrepancy. The gap in Soviet understanding was not resolved for years. What the men at Kubinka were missing was not a single design feature, but a combination of decisions taken at Chobham in 1943 and 1944. Decisions that had been made for reasons entirely unconnected with nuclear survivability. The features that mattered were 3, and they were connected. First, the single-piece cast turret from English Steel in Sheffield. Cast armour distributes shock loads through the mass of the metal without the stress concentrations that welded joints produce. When the Emu Field shock front hit the Centurion, the turret behaved as a monolithic block. Soviet T-54 turrets of the period were also cast, but of a shallower profile with thinner walls at the sides and rear. The British casting was heavier and thicker in section, a legacy of the naval gun-house technique that Sheffield had scaled up during the war. Second, the Horstmann suspension. Sidney Horstmann had patented the design in the 1920s. It used horizontal coil springs mounted externally to the hull in bogey pairs. The external mounting meant that shock transmitted through the road wheels was absorbed by the springs before it reached the hull. At Emu Field, high-speed film showed the tank rocking violently on its suspension, but the hull itself deforming only marginally. Soviet tanks of the period used torsion bars mounted through the hull floor, which transmitted shock directly into the fighting compartment structure. Third, and least obvious, the interior layout. The Centurion's ammunition was stowed low in the hull, below the turret ring, in armoured bins. The 20-pounder projectiles were separated from their propellant charges. When thermal and blast effects entered the fighting compartment through the periscopes and vision blocks, they encountered no exposed propellant. Soviet designs of the period, prioritizing rate of fire, stowed one-piece rounds in racks around the turret basket, closer to the crew and closer to the hull walls. This produced the cook-off events that Kubinka had recorded at Totskoye. None of these features had been designed with atomic weapons in mind. The cast turret was a wartime production expedient. The Horstmann suspension was a cost and maintenance choice. The ammunition stowage reflected British tank doctrine that valued crew survival over rate of fire. But together in October 1953, they produced a tank that survived what Soviet contemporaries did not. The GRU eventually reached this understanding through a longer route. The 1954 and 1955 issues of the British Army Review and the Journal of the Royal Armoured Corps carried unclassified articles by FVRDE staff on the Centurion's development, some of which referenced the Australian trials in general terms. Aviation Week, published in New York, ran a piece in June 1955 that mentioned the Emu Field armour test. The GRU resident in London, Colonel Nikolai Rodin, working under diplomatic cover as Nikolai Korovin at the Soviet Embassy in Kensington Palace Gardens, was tasked with running down the technical specifications. Rodin's file, opened by MI5 under the codename ELLI, and later closed when he was withdrawn to Moscow in 1961, includes evidence that he attempted to cultivate personnel at the Royal Armoured Corps Centre at Bovington. The attempts were unsuccessful. MI5's B branch, under Graham Mitchell, had Rodin under surveillance from 1955. What the Soviets did obtain came through other channels. A Chertsey draftsman named Frank Bossard, arrested in 1965 by Special Branch and MI5 after a joint operation, had passed guided weapons documentation to the GRU in exchange for cash payments. Bossard was tried at the Old Bailey and sentenced to 21 years. His espionage did not, so far as the surviving records show, include Centurion documentation, but the case illustrated the vulnerability of the technical establishment. The Centurion's secrets travelled by other means, through the tank itself, exported to Israel, Sweden, the Netherlands, Denmark, Switzerland, Jordan, India, Australia and South Africa. By 1960, Centurions were in service with 16 armies. The Israeli purchase was the largest. Between 1959 and 1967, the Israel Defence Forces acquired approximately 300 Centurions from British and residual Commonwealth stocks. The tanks were reworked at the Tel Hashemer depot near Tel Aviv, re-engined with American diesels and re-gunned with the L7 105mm developed at the Royal Ordnance Factory, Nottingham. The L7, which would eventually equip the American M60, the German Leopard 1, and the American M1 in its early marks, was itself a British contribution to Western armour that emerged from Centurion development. At the Golan Heights in June 1967 and again in October 1973, Israeli Centurions engaged Soviet T-54s and T-55s in the largest tank battles fought since Kursk. The Valley of Tears engagement of October 6 to 9, 1973, in which the 7th Armoured Brigade under Colonel Avigdor Bengal held a Syrian force of approximately 500 tanks with fewer than 100 Centurions, produced kill ratios that Kubinka analysts studied for years. The Centurion's frontal armour, mounted at 57 degrees, deflected T-55 armour-piercing rounds at combat ranges. Its L7 gun defeated the T-55 at ranges beyond which Soviet crews could reply effectively. The engagement was not a nuclear battlefield, but the survivability that Emu Field had demonstrated translated directly into conventional performance. In London, the Ministry of Defence tracked these engagements with attention. Dennis Healey, Secretary of State for Defence under Wilson from 1964 to 1970, had reduced BAOR to 4 divisions and cancelled the TSR-2, but he had preserved Centurion production and its successor programme. The Chieftain, the replacement Healey approved, entered service with the British Army in 1966. It carried a 120mm rifled gun developed at Nottingham, a fully stabilised fire control system, and a reclined driver position that reduced the frontal silhouette. Its glacis armour was thicker than any previous NATO tank. The Chieftain drew directly on Emu Field. Its designers at FVRDE, working under Colonel Kenneth Robotham, incorporated NBC overpressure filtration as a baseline requirement rather than an accessory. Crew survival in a tactical nuclear environment was designed in from the first drawings. The gun stabilisation and the thermal sight development at the Royal Radar establishment at Malvern were driven by the assumption that Chieftain crews would fight in conditions of degraded visibility, whether from dust, smoke, or nuclear thermal effects. By 1972, the British Army of the Rhine fielded 900 chieftains across 4 armoured brigades. The 1st Armoured Division at Verdun, the 2nd Armoured Division at Lübecker, the 3rd Armoured Division at Soest, and the 4th Armoured Division at Herford formed the shield of NATO's Northern Army Group. Their planned withdrawal position was the Weser. Their anticipated engagement was against Soviet Third Shock Army, whose forward divisions at Magdeburg and Halle fielded approximately 1,500 T-64s and T-72s. The intelligence estimate that mattered was JYC 7321, produced by the Joint Intelligence Committee in autumn 1973, and read by Prime Minister Edward Heath before his general election defeat in February 1974. It assessed that a Warsaw Pact offensive against NATO's Central Front would open with a nuclear release authorized at Army Group level, targeting NATO nuclear delivery systems, command posts and forming up areas. The window between initial detection of Soviet mobilization and the first nuclear detonations was estimated at 48 to 72 hours. The chieftain crews in Verdun and Soest trained to fight in that window, and to continue fighting after it closed. The training was informed ultimately by a tank that had sat in a South Australian desert 20 years earlier. Chobham Armour was the next step. The military vehicles and engineering establishment at Chertsey, the successor to FVRDE, renamed in 1970, began work on a composite armour scheme in the mid-1960s under the direction of Gilbert Harvey. The project was classified from the outset. Harvey's team, drawing on FVRDE's accumulated data from Emu Field and from subsequent conventional trials at Kirkcudbright and Lulworth, developed a sandwich construction of steel plates, ceramic tiles, and elastomer layers that defeated shaped charge warheads to a standard beyond anything monolithic steel could achieve. The armour was tested at Chertsey against Soviet 115mm and 125mm shaped charge rounds recovered from the 1967 and 1973 Middle Eastern Wars. The classification of Chobham armour was among the most tightly held technical secrets of the late Cold War. Its existence was not officially acknowledged until 1976. When the United States began developing the M1 Abrams at Detroit Arsenal, American armour engineers were briefed on Chobham under a technical exchange agreement signed at the Ministry of Defense in December 1976 by Fred Mully, Secretary of State for Defense, and Donald Rumsfeld, then in his first tour as United States Secretary of Defense. The M1 entered service in 1980 with Chobham-derived armour. So did the Leopard 2. The British Challenger 1, developed at the Royal Ordnance Factory Leeds and entering service with BAOR in 1983, carried the full British specification. The GRU pursued Chobham through the 1970s and 1980s, with the priority it had once directed at the Manhattan Project. The Residentura at Kensington Palace Gardens ran illegals, cultivated sources at Chertsey and Leeds, and pushed particularly hard against the technical exchange with the Americans. MI5's K branch, under John Jones and later Cecil Shipp, worked the counterintelligence problem in parallel with GCHQ signals intercepts at Cheltenham. The result was containment rather than complete security. When Oleg Gordievsky, the KGB resident designate in London who had been recruited by MI6 in Copenhagen in 1974, was extracted from Moscow in July 1985 through Operation Pimlico, his debriefings at the fort in Gosport confirmed what MI5 had suspected. The Soviets had partial technical specifications but had not been able to replicate the manufacturing process. The Soviet response was the T-64B and later the T-80U, tanks that carried composite armour of their own design, incorporating steel, ceramic and glass fibre layers. The Kubinka engineers had eventually solved the problem the Emu Field data had first posed to them. But they had solved it 30 years later and with a design philosophy that still differed from the British approach. The Challenger 1 saw combat in February 1991. The 7th Armoured Brigade under Brigadier Patrick Cordingley, deploying as part of the 1st Armoured Division to Saudi Arabia for Operation Granby, crossed the Iraqi border on February 24, 1991, and engaged elements of the Iraqi Tawakkalna Republican Guard Division at Objective Platinum. The Iraqi force fielded T-72s of Soviet manufacture, some upgraded with locally produced composite armour known as the Assad Babel variant. Over 3 days of engagement, the 7th Armoured Brigade destroyed approximately 300 Iraqi armoured vehicles, for the loss of no challengers to enemy fire. One challenger of the Royal Scots Dragoon Guards recorded a confirmed T-72 kill at 5,100 metres on February 26th, the longest tank-on-tank kill of the war. The Cold War ended in August of that year with the collapse of the coup against Gorbachev in Moscow. The Soviet archives began to open. The Kubinka files became partially accessible. Michael Kettle of the Ministry of Defence's Defence Intelligence Staff travelled to Kubinka in 1993 as part of a joint British-Russian technical exchange authorised under the post-Cold War confidence-building arrangements. He was shown, among other exhibits, the Soviet trial reports from Totskoye in 1954 and from later exercises at Semipalatinsk in the 1960s. He was also shown, in an office rather than a display hall, a translated summary of FVRDE report number 47/54. The Russian technical officer who produced it told Kettle that the document had reached Kubinka in the late 1970s. Through channels the officer declined to specify. It had been studied, Kettle was told, for many years before the T-64B design was finalised. Kettle reported this in a minute to the Chief of Defence Intelligence, filed at the MOD main building in Whitehall, and later transferred to the National Archives as DEFE-24. The minute observed that the Soviet delay in reaching a comparable design was probably attributable less to intelligence failure than to industrial and metallurgical differences. Sheffield's naval gun foundries had no direct equivalent in the Soviet armour industry. The techniques that had produced the Centurion's turret in 1946 were not easily replicable at Nizhny Tagil or Kharkov, even with complete drawings in hand. The Centurion itself, Army Registration number 169041, returned to Australian Army service after Emu Field. It was refurbished at the Bandiana workshops in Victoria, deployed with the 1st Armoured Regiment to Vietnam in 1968, took the RPG hit near Coral Base on May 6, 1969, and was recovered under fire. The commander, 2nd Lieutenant John Salter, and his crew survived. The tank was repaired in-country and returned to duty. It was finally retired from Australian service in 1976 and placed on display at the Robertson Barracks in Palmerston, Northern Territory, where it remains. The tank is not in any accepted sense a working monument. Its engine is inert. Its gun is welded. But visitors who read the plaque learn that the atomic tank survived a nuclear detonation, a war in Vietnam, and 30 years of routine soldiering. What the plaque does not say is that its survival at Emu Field shaped the tactical planning of the British Army of the Rhine, the design of the Chieftain and the Challenger, the American Abrams program, and, by extension, the armoured forces that entered Kuwait in February 1991. The Cold War in Central Europe never became hot. The armoured battle on the North German plain that generations of BAOR officers trained for did not come. The chieftains at Herford and Verdun left Germany in the 1990s without firing at a Warsaw Pact target. The Centurion story is often told as though this outcome renders the exercise pointless. The men who took the decisions at Great George Street in 1953 did not see it that way. Slessor, Harding, Cole and Penney were building the conditions under which the war would not have to be fought. Their calculation was that a Soviet general staff which read the Emu Field data and its successors would think longer before crossing the Elbe. The tank in the desert was one piece of that calculation. Its survival and the Soviet inability to match it for 30 years is one measure of what British engineering and British intelligence contributed to the peace that held from 1945 to 1991. The engineers at Kubinka were baffled in the end, not by a secret but by a tradition. Sheffield foundries, Chobham drawing offices, Barnbow assembly halls, that the Soviet system could not readily reproduce.